Hello, everybody, and good morning. Today I'm going to be putting two videos up, one on additive and one on subtractive color mixing. So on that first video, we're going to talk about additive color mixing, which is this video, and we're going to ask where does it apply, what are primary colors in additive color mixing, what's the color triangle, what about brightness and non-spectral colors, and then how it applies to painting. And that'll be something a little bit different because when we first talk, we're going to talk about where does it apply. And additive color mixing applies when we're talking about mixing light. So you'll see it a lot when you think about um, color monitors, our cell phones, our TVs, and nowadays we see a lot of additive color mixing, but when it was first sort of investigated, we didn't see a lot of particular use for it. But today, the RGB on your TV is color mixing, where we sort of can set the mixture of the reds, the greens, and the blues, and those are the only colored pixels that we actually have. So the next question is, what are primary colors? Um, and like I might have insinuated there, for additive color mixing, the primary colors we typically choose are blue, red, and green. And the thing that's important about primary colors is that um, the third one isn't a mixture of the first two. So I don't make green by mixing blue and red, for example. So they're not mixtures of each other. And when I combine all three together as light in the correct proportions, I get white. And then I can think about, well, what happens when I actually mix them? So if I have red, like I have up here, and I mix it 50-50 with blue, I end up with the color cyan. And when I'm mixing colors, the color I'm mixing will be on a straight line between the two colors that I'm mixing. So red, blue, 50% of the way is cyan. So I can think of any color, any color, as a mixture of some fraction of red plus some fraction of blue plus some fraction of green. So cyan would be 0.5 red plus 0.5 blue. And the book goes in and says that the actual units we're talking about don't really matter because it's just a fraction or ratio of the total units that matters. And that's what these A, B's, and C's are. And these A, B's, and C's, when I write them this way as these ratios, always add up to 1. So on my color triangle, I think of red as being 1, 0. So 1 red, 0 green. And that also means 0 blue because they all have to add up to 1. But I only give the red and the green ratio. So green would be 0, 1, and blue would be 0, 0, with the third complement, this B here, being whatever's left over to add up to 1. 50% red and 50% green gives me yellow, which is a little bit hard to see here, but it's right here. 50% blue and 50% green gives me cyan. And then all the rest of the colors are, all the rest of the spectral colors are sort of available in this triangle. And that's not 100% true, but we'll talk about colors that lie outside the color triangle a little bit later. And as we move toward the center of this, at the center of this color triangle here, let's do that in black so we can see it a little bit better, we would have white. And as I move toward the center, what I have is the non-saturated colors. And I have the saturated or pure colors on the edges. So if I'm on the edge here, one of these A, B, or C, so if I'm on the edge, that means A or B or C is equal to 0. And in that case, I have no extra white, which means that I have a saturated color. So this would be saturated red. And as I move in this direction, I would have less and less saturated red. But if I move in this direction, I'm changing hue and I'm still a pure color. So as I move on a straight line between my color and the white center, I'm not changing hue, I'm just changing saturation. As I move other directions, I am actually changing hue if I'm not moving on a straight line between the color of choice and the center. So that means this picture, which is a triangle, forms the color triangle. And the color triangle gives me saturation and hue. So I might say that I also have all the other colors here. So red and green should give me brown and a variety of other sorts of ideas. So I'm going to jump to a little simulation now. And we can sort of see what's going on here. So if I choose this guy right here, this red, blue, and green, I can see that if I shine red light, I have red, and if I shine red and green, I have yellow. If I reduce the amount of green, I end up with a different hue. So there's, say, orange. And if I did blue and green, I would have cyan. And if I add some red in here, I've changed the saturation, but it's still this light blue color. If I did blue and red, I'd end up with magenta. And if I did red and added some white by adding blue and green, I end up with pink or low saturation red. And this is all interesting and is all information that's sort of given on the color triangle. But if you notice, one thing that's happened here is I've always pushed one of these dials up to maximum. So that means I'm always at a sort of maximum brightness. And if I put all three up, I end up with white. Well, what if I want a color like olive green or brown? Well, brown, what I need to do is I need to get orange. And then if I take my orange and I reduce the brightness, so I don't have all of them at this maximum value, then I end up with a brown. So brown is just a low brightness orange. Olive green is just a low brightness green. And I could think about a non-saturated olive green, for example, which would be a low saturated, or a little bit of white, but a low brightness color as well. So now heading back here, we talked about brightness. So brown is just a low brightness orange. And we could also see things like black is just all zeros. And gray would just be a low brightness white, sort of. So halfway up on all the dials. This simulation comes from the University of Colorado Boulder and their free PHET app. So if you want to take a look at that, feel free to zoom in and take a look at it on your own. All right. This brings us to non-spectral colors, and non-spectral colors are the magentas and the purples. And these colors don't have a specific wavelength associated with them. So if I split white light, I never end up with magenta or purple. They come specifically and only from color mixing. And there are purples and magentas that can't be gotten through this RGB scheme. And as a matter of fact, there are colors outside of the color triangle that we can see, but aren't able to be represented. And that includes things like spectral cyan, because the cyan we have comes from two mixed colors. And a pure cyan, just the wavelength associated with cyan, would look like a even purer or more saturated cyan. All right, so there's our little discussion about additive color mixing. A subtractive color mixing video will go up separately, so you can watch them each one sort of individually. I look forward to seeing you in that video next. Bye.